All right. Following Eric is always a tough act. One of the things Eric forgot to emphasize in his talk is that success isn't all it's cranked up to be. So, as you'll see, my goal here is not necessarily taking over the world. So, what's Newspeak? Newspeak is a language that we're working on at Cadence with what I take to be a rather distinguished pedigree. So we have, essentially, we're directly descended from Smalltalk with a bunch of influences. The bigger the circle, the bigger the influence. The smaller the circle, the less influence. So what would you conclude from this graph? We'll assume you're sort of like Sherlock Holmes and can make a lot of really accurate predictions based on almost no information. So obviously, we're based on Smalltalk. It's a class-based language. It's dynamically typed. It's reflective, and that's in bold for a reason, because that's really important. And, you know, reflective means the whole deal. You can change anything at runtime. All the objects get relayed. Everything happens the way it's supposed to. And what else would you conclude from this diagram? Well, you know, we're heavily influenced by self. So what does that tell you? It tells you that this is what I call a message-based language. Now, message-based, finding the right term is a bit of an issue. You should think loosely coupled, not necessarily asynchronous. Eventually, we'll get round to doing an actor library and doing asynchronous calls through for actor-based concurrency. But what's important here is that essentially every name that you reference in Newspeak is late-bound. If you want to think of it very concretely right now, that means it's essentially a virtual method call, every name. I wouldn't call it method-based because that brings to mind all kinds of aberrations, final methods, non-virtual methods, static methods, you know, oxymorons. So we don't want any of that. We want real methods. And so what does this, you know, imply more concretely? For example, you never access a variable directly. So what does this look like? This is a slot definition. You can think of it as an instance variable declaration, if you will, or field declaration. And we have this slot named ID. And the equal sign is not assignment. There is no assignment operator in this language. You never have any variable to assign to. Whenever you declare a slot, you access it through accessor methods. That's the only way you access it. And so this in particular is an immutable slot because that's what equal means. And you know, don't worry about what this expression evaluates to. Basically, we'll get into some detail in that in a few minutes. But this slot will be initialized to the value of this expression. So it's immutable because what we do when we see such a slot definition is we introduce a getter method. And we don't introduce a setter method. So there's no way for you to change it. Now, if you wanted a mutable slot, you do this. And this would tell you that it's a mutable slot. And then there'd be a getter method and a setter method. And one of the interesting details here is this thing is the only thing that makes this language imperative. And it's a completely imperative language. But take out this, and it's a completely functional language. Now, there's one more thing that you can do that will make it non-functional because it's reflective and you can do almost anything to it. So if you really want it to be functional, you'd also want to control who can do reflection, who can do what to whom. And that's another self-based influence. We use a thing called mirror-based reflection. I'll say a few words about that later. But essentially, it's a way of giving you very fine-grained control of who does reflection, right? It's not some diffuse functionality that is always on, that then you have to turn some special security mode on to try and disable it, etc., like some systems I know. And I'll show you a bit more about that later. But again, this is an idea that comes from self as well. So what else would you learn from my sort of pedigree diagram here? Well, beta. What does beta tell you? Beta tells you there's nested classes. Unlike Smalltalk, classes can nest. Now, if you put 2 and 2 together, you'll realize that between these two influences, we have class nesting and message-based programming. And what that starts to get interesting because there are implications to this. For example, this means inherently that all nested classes are virtual classes. Why? Because the names of the classes you're referencing to are not necessarily classes. They are simply method calls that will get you a class back, which can be overridden in a subclass by another class, by a slot definition, by a method definition, by whatever you want. Your code is representation independent. no code anywhere, not in your clients, not in your subclasses, not in the class itself, really knows what is a variable and what's a slot and what's a class. Another thing that this implies is that essentially all the classes are mix-ins. Because when you define a class, if you say what the superclass is, that's very nice, but statically you don't really know what that is. So inherently you have to compile every class as a mix-in. And that lets you do things like class hierarchy inheritance. So you can take a whole library, a whole framework, if you will, stick the classes in an outer class, and now you have something that you can override in a subclass of that outer class, and say override, say, one of the classes in the library. And because everything is dynamically bound, when you instantiate this new subclass of the library, you get a new library that implements the change. So you can do inheritance on the scale of entire subsystems. And that's fairly nice. I don't know if I'll have time to actually show you an example of that, but come see me later if you're interested. So before I go into this little influence, I want to show you another diagram which shows you things that aren't a direct inspiration but have a lot in common anyway. So Dan mentioned E in his talk the other day, and E is a language that was designed for security, and there are some commonalities. And security is something that I believe you have to take seriously. I'm not going to pretend that the system we've built so far is anything like secure. However, I think that if you put in foundations for security early on, you might have a chance of making it secure. And if you don't put in the foundations, you'll never make your system secure. So one of the things that people talk about is this object capability model, the idea that security is basically done by capability. Another one of those great ideas from the golden age of computer science, 60s and 70s, that will ride again. And objects are a very good fit with that, because basically you give someone an object that can do something, that's the only way they can actually do something. The only way they have a capability, for example, to access the network or open a file, if there's some object that knows how to do it. So we can control who has what permissions by essentially handing them those permissions as objects. And this is an idea that the E people have pushed fairly hard. I've always believed in this. They've gone and done a lot of the work to show that it's viable. What this implies at the language level is that objects really have to do real data hiding. So we have public, protected, and private messages, and that's enforced. And there should be a little star here that says that I'm lying, because that actually isn't implemented because we're running on top of a Squeak VM where all methods are public. So it's all wide open at the moment. In a few months, we'll get round to fixing the VM to deal with that. But that's the concept. Another thing we have in common with E is there's no static state. So in Smalltalk terms, no globals, no pools, no class variables. In your terms, no statics of any kind. Anything that starts with static is generally a bad idea. So this, again, is something that I've been saying in various talks for about 7, 8 years now. But the E people don't do static state because it's bad for security. It's bad for it's one of those ideas that has almost no upside and yet is widely used. So it's bad for a lot of other things, but this is something we have in common. Things we don't have in common. As I said, Newspeak is reflective. This kind of powerful reflective capability and security, there are people who see some sort of tension between these two things. And the people basically, in the spirit of, throw the baby out with the bathwater, decided they wouldn't do reflection because that was a problem. I believe Mark Miller, who works on this, is now investigating this sort of issue, how to fix that. So mirrors, again, which I mentioned earlier, basically, among their many nice properties is that they give you a form of capabilities for reflection. And you can exercise very fine-grained control if you design your API right as to who can reflect, if at all, and on what, and to what degree. So all these things tend to fit together. Scheme. Well, there's hardly anything in common with Scheme, really. But there is one thing I'd like to mention. PLT Scheme has this notion of units, this modularity system that's really nice, that's very component style. And again, it's not an inspiration from this. I did my PhD thesis many years ago on modularity, so a long time before the units work. But I've always liked that drift, and we're doing sort of something that has some commonality with that in terms of component-style modularity. And how does that work? Well, a top-level class, essentially we regard that as a module definition. So that's a class that isn't nested within another class. And we have this rule that a top-level class does not see the surrounding scope. Classes that are nested see the surrounding scope. You can do the usual things of sharing by nesting classes within each other and accessing shared state and so forth. But at the top level, they don't see the surrounding scope. In fact, they have to be deeply immutable. Not the objects they create. The classes are deeply immutable. Classes should have no state. They're programs, they're behaviors. This is something elementary that, again, seems to get screwed up all the time. But because of this, what does this mean? It means that any name in a module definition had to be defined within that module definition or inherited from its superclass, which basically also had to be a module definition or object because of this requirement, essentially. And so any access to the outside world has to come through the formal parameters of the factory methods that actually instantiate these module definitions. That's the only way you're going to get anything coming in. So when you instantiate a module definition, you get a module, and you pass it objects, which are its only connection to the world, the only way you'll open a file or talk to the network or do anything. So those objects are capabilities again. So you get a per module sandbox. So all of these things kind of seem to be a very good fit together. The things just sort of fall out. So this is the kind of quick overview. We haven't said what influence we had from Scala, so not much, but something. Some details of object construction. Object construction in Newspeak, I don't think I'll have a lot of time to talk about it, but it's sort of a compromise between how Scala does it and how Smalltalk does it. And I think it gives us some nice properties. Something that may be coming, we're considering, since Martin Odersky has finally figured out how to do pattern matching while preserving data abstraction, then it's finally legitimate to do it. And so we may add something like that, but that's still, all of this is very much evolving. We're part of a real project that's doing an application. There's this problem that when people are doing an application, they have a great difficulty programming to a platform that doesn't exist yet. And so we didn't figure out a way around this. Instead, we started them off on Squeak, and we've been mutating it as we go along into the language we want to create and dragging them kicking and screaming on the way. And every few months we put out a new version. So we have Newspeak 0, 1, 2, and 3 pretty soon. And so everything's still changing. But we're a very small group, and this is still manageable. So another influence of Scala is the example I want to show you. How many people know about parser combinators here? Yes, you know about them, do you, Eric? How remarkable. I figured not many. So I'll explain what this is. Again, this example was, in some sense, was inspired by Scala, because the idea of applying this in an object-oriented setting came to me by looking at some of the Scala tutorials. The design I came up with was very different from those, but interestingly enough, the second generation Scala parser combinator library called Sparsec is actually very, very similar to what we're doing. I wonder where they got that name. So everybody knows BNF, and this is a production, that describes a standard identifier. Almost every language has something like this. And we saw this one before. So this is actually, as you already know, is a slot definition. And the difference between these two, they're fairly similar. The difference is this is executable code that will actually parse this thing. So how does that work? As we know, we have a slot that's supposed to be evaluated to this expression right here. And this expression, everything in Newspeak is basically a method invocation. And the top-level method invocation in this expression is a little red guy there, a comma. So comma is a legal identifier for methods. And generally, all kinds of combinations of those kinds of characters are valid method names. And all this comes from the Smalltalk and the Smalltalk family, like self and so forth. And if you have a method name that is one of those things, it's used in an infix form. But this is just syntactic, right? It's a regular method. There's no operator overloading or anything stupid going on. It's just straight, method definition and method override. So a method always has a receiver, or target if you want. And in this case, it's letter. This is a method call, of course. It's not a variable. There's no such thing as a variable, really. And so when you evaluate this, you'll get a parser object. This particular parser object will parse a single letter. And then you'll evaluate the arguments. And the argument here is, of course, another method invocation. The method is called star. You might have this urge to put a dot right there, but suppress it. Basically, there is no need for the dot because the dot comes from languages where there are many, many kinds of operators, and one of them has to denote, selecting from a record or a struct or an object. And there aren't. There's only one operation here, so there's nothing to distinguish. You can make it implicit. So there's a receiver to star, and that's this expression, which itself is a method invocation. It's another, pressed the wrong way, yeah. Another one of these binary methods, and it has a receiver, and that receiver will again give us another object that parses a letter. Then we evaluate the argument, and that gives us an object that parses a single digit. Now we can finally do something with an interesting method, and this method, this is the alternating combinator. What it does, it represents alternation in the grammar, and it builds you a new parser using the target of the method invocation and its argument. And what it'll do, it'll ask the target to parse. When this is asked to parse, it'll basically ask the left subtree to parse, and if that succeeds, it's happy. That's the result. If not, it'll ask the right tree. And if none of them, if they both fail, it'll fail. So this is not quite BNF. This is what's called PEGs, parser expression grammars. It's alternation with priority to the left-hand side. This is almost always what you want. And interestingly, there's actually a nice formalism describing this, which I only read about after I started doing this library, because it just seemed the right thing to do anyway. But it's always gratifying when someone smarter than you actually figured it out. So then we can do star. Star does what you'd expect, right? It basically, you think of this as calling this guy in a loop and collecting the results. And if it fails, then it stops. But it doesn't fail, it succeeds. So if there was nothing here, it'll fail right away and you get an empty collection. There was nothing. If there's n of these, it'll parse n of these and stop when the right pattern ceases to exist. So it's exactly the 0 or more occurrences. And finally, we use this. We evaluate the whole method with comma. And that's the sequencing combinator. So that basically does do this, then do that. And if either of them fails, you fail. So altogether, we've constructed an object here that'll parse a letter, then it'll parse 0 or more of either a letter or a digit, which is just what it says here. The nice thing is we can write this in a way that looks almost like a grammar and actually execute it, because this is all a very nice compositional paradigm, all of which comes from functional programming. Occasionally, these guys do something right. So I want to stop and say why this actually looks good, because there's something that needs to be said about this. And the way to decide that something looks good is often to look at something that looks bad. So this is your standard gunk. And why is it really bad if you compare it to, say, the BNF, which is a language designed for this, or even to Newspeak, which is pretty close to that? It's bad because all the stuff written in blood. So the blood splatters come from things that shouldn't be there. They have to do with the solution you choose to use. They're solution space cruft. Pollution, basically. Why do we have all these parens here? Well, we need to, when we call a method with no arguments, you'd think we could pass it no arguments, but no, we have to pass it an empty list of arguments. Why do we have to do that? Because we can't tell whether it's a method call or a variable. Well, we don't have variables, so we don't have to tell. I've explained why dot is just, another drop of blood. And again, there's a statement separator, which a lot of languages need. Some languages don't, but we won't get into that. And then none of this has to do with the problem of describing the grammar that you want to parse, right? It's just part of your solution that intrudes on your reasoning. The purple stuff actually does have to do with the solution, except that it's in purple because it shows that generally you can't express this the way you'd like. It's not succinct. You can't use the operators that you're used to and things like that. So, of course, BNF is special purpose designed for this, and there's nothing really that's redundant here. Newspeak does fairly well. We have a statement separator, alas, and we don't do sort of postfix operators. But and we have an explicit sequencing operator, right? In BNF, the sequencing can be implicit because that's the most important operation. In grammars, most things follow another. You make the most common operation implicit. In an object-oriented language, the most important operation is method invocation, which is why all languages should make that implicit. And we actually do. So, and we try to make, sequencing really small, so it'll kind of look kind of decent. So there's a real I stopped to talk about this because it's really a fundamental point, and always when you have a point you want to make, you can always quote Perlis. There's a website with Perlisisms. It's fabulous. And so in this case, what makes programming languages low level is the fact that you have to deal with stuff that really isn't part of the problem. And we want to minimize that. I think that's a useful perspective. So let's try and move along here. What does an actual complete grammar look like? Here's a Newspeak class. It has a bunch of slot definitions. Basically, every production in the grammar has a slot, which is initialized to a parser that'll process it. So a digit is a character between 0 and 9. These dollar things, they're small talk character literals. We're probably going to change that to something a little more palatable to the masses. A letter is a character between lowercase a and lowercase z, or a character between uppercase a and z. ID we've seen. Identifier is a little interesting, right? This was identifier, so why do we have this? Well, BNF sort of waves its hands, being designed by sort of mathematically oriented people. It sort of says, yeah, there's an alphabet somewhere. It is beneath us to stoop to worry about how you actually extracted it from real character streams and so forth. Nonetheless, you actually have to tokenize. And this is scannerless parsing here, right? These are all actually lexical productions. You don't have to do it that way, but it really works out very nicely if you do, as we'll see. So this operator takes a parser and gives me a new parser back. Again, it's all very functional. What the new parser does is it skips any leading white space and perhaps comments. And it wraps the result of this guy in a token, which will typically add things like where in the input this was, which is another one of those pesky little things that real systems need to know about. And we can take a character literal and turn it into a parser using this operator. To keep this on one slide, we only have one expression, which is just identifier. And this is more or less the small talk return statement, which is this hat character followed by an expression. So in your typical language, this would have been a return keyword. So this is a complete little grammar. And these things actually do exist. Oops. Right? So let's see if we can make it bigger. So this is Squeak, except this is Newspeak browsers, and here is literally the same code. So I just wanted to show that it actually does exist. I don't think I have time to demo very much in the next 7 minutes, because there's a lot I want to say. So back to the main show. Go away. So another interesting thing about this is, where are the semantic actions? You know, it's all very nice to tell you that this is a sentence in the grammar and all that, but sometimes you actually wanted to maybe do a little bit more. So how do you do semantic actions? Here's a combinator that'll let you do semantic actions. Basically what it'll do is it'll parse the same language as the receiver here, except that it will take the result and feed it to this closure. This is a closure in Smalltalk. Let the closure do its thing, and then use that result as the overall result of the entire parse. So, you know, the tree structure looks like this. This was our original sequence of hat and an expression. And here's wrapper. And the net result is I'll build me a return statement AST. And because the grammar is all self-referential, all the other productions that I'm referencing here will also be giving me ASTs, and all compose sort of automatically nicely. So we can see we've got grammar here, semantic action here. And I started, the first time I did this, I started formatting these nicely so I'd keep them separate, and then it occurred to me that I could do better, because I could actually put all this stuff in a superclass, and I could put the semantic actions in a subclass completely separated. What happens here, I assign a slot, as I said, to the pure grammar, and I define a method that overrides the slot. Remember, this is what message-based programming does for me. I can replace slots with methods, and no one cares, and vice versa. And so here, I call the superclass's return statement, which will give me this parser that just parses the grammar. I'll apply the wrapper combinator to it and get a new parser that actually does what I want, parses this fragment of the grammar, and builds the AST. So now they're completely separate. And I can do this for all the productions, so I can do this for return statements. I can wrap identifiers in variable ASTs and things like that. And again, right, we should be able to find this somewhere. Is this it? Where is it? It's this guy, isn't it? Right, so here we are with the exact same stuff.
This is very hard to do with just functional programming. virtual methods here. It's beautiful.
Thank you. I wouldn't have said it myself, of course, but yeah. Well, the thing is, I was very curious. I asked the leading lights of the functional community, had this been done before? Right? It seemed fairly obvious, right? And no one had done it. And some of them said, "Why would you want to do it?" And various other things that you'd expect from leading lights. The thing is, I think the reason it hasn't been done is that all these languages are statically typed, and it's a bitch to type this thing. And you basically need a type variable for every production in the grammar. And to generify this monstrosity, which will have dozens of type variables and pass it through you don't want to think about it. So it's hard. Of course, you can also do things like just extend the grammar. So we added an if statement, right? Just use the subclassing in the language. We've got essentially BNF embedded here as a domain-specific language in a general-purpose language. There's one thing that's interesting going on here is that there's, very often in grammars you've got mutual recursion. So if refers to this, if statement refers to statement, and if statement refers to statement refers back to if statement. So when we build this, we tend to get in trouble, right? Because there's a loop here. And in lazy language, this isn't a problem. There are good things about these Haskell things. But if we do this, it seems that we go ahead, we fill up the slots with parsers as we go along. And eventually we're here, and we're going to ask if statement to build a parser. And it'll call statement to get this thing, but statement isn't initialized yet, so it's nil, and bad things might happen. So what do you do about this? As I said, in Haskell, they never worry. I mean, ordering, they don't stoop to worry about what happens first, what happens later. It's all taken care of. Now, the usual thing in applicative order languages, in eager languages, in functional languages, they wrap everything in a lambda. And that's what you see here. The red stuff, these mean in Smalltalk they're closures. Fortunately, Smalltalk has the really coolest closure syntax of any language, functional or not, because it's much more lightweight than a lambda in, say, ML or something. But it's in red because it's still cruft. It still has nothing to do with the problem. And so my first library actually did this sort of thing until I realized how stupid I was. And basically, we have something much more powerful than laziness. We have reflection. So we can actually analyze this. Our library can actually look at this and actually see what the slots are and fill in stand-in forward referencing parsers. So that when I go through, the library sees to this, and then I go along happily, and there's no problem. And I've basically gotten rid of the loop here, right? I've got this forward reference node. And of course, I have to fix the loop somehow and get the forward reference to eventually refer forward to something. And that closes the loop. And that's how I can get away from having to deal with closures. And it's kind of a neat trick. So what else can we do? Of course, if we want to add semantic actions to the original, to this extended grammar I showed you, well, I have semantic actions for most of the grammar, but I have this multiple inheritance problem, right? One class inherits from the grammar and extends it. One extends the grammar with a parser. Now I want a parser that extends both. So there's the solution for that is mixins, of course, and we can do that. And that also actually exists somewhere right here. It's actually given a name here as superparser. And then example parser 2, I think it is, inherits from superparser. So the thing, it actually does what I'm claiming it does. And I'm running out of time, so what else can I say? The main point here is that it's a shared executable specification. Right? I have one grammar. It's separate from everything else. I can reuse it. If I have multiple backends, I need different ASTs, I can use the same grammar. If I have an IDE, and I want to do different things with a grammar. I want to do syntax coloring, pretty printing, post-processing, all these things. Some of these things don't want to actually build an AST with a regular parser. The syntax coloring is a lexical operation. You want to colorize comments and stuff. That information gets lost when you build the AST. So it's really nice that you can use this grammar at the lexical level as well. Do scannerless parsing. And it's nice that you can actually share this code and not ever have to copy it and worry whether you're really parsing the same thing. So it's kind of, for people like me who like to do these kind of tools, it's really cool. And it just happens to be a nice example of how things have worked out. I have the feeling that I'm just about out of time. It's a bunch of related work. And the main point, we don't have time for backup slides, that's for sure. Right, all these things are of a piece. the message-based stuff, the component-style modularity, the virtual classes, the hierarchy inheritance, the object capability model and what it does for security, actors, the mirrors, all of these things play together. Didn't talk about pluggable optional types, but obviously this is almost useless if you try to type check it. There's a whole academic cottage industry of family polymorphisms that some of my good friends engage in, and it's very nice. The thing is they obsess over the types. They never do anything useful with this. They just worry how to type check it. And it's really hard to type check. You find that you probably can't do much useful at the state of the art. There's work on this all the time. Eventually someone may figure it out. The point is to figure out what's the useful thing to do and type check it later. So all of these things play together. And that's all I had time for. If anyone wants to know more about this, it doesn't run on .NET, doesn't do anything. I'm here by accident. And, it's come see me later. Question? Where can you get it? Are you the CEO of a large corporation?
No.
I wish you were. If you can get people to write on company letterhead how much they'd like to experiment with this, it would help me. I would love to get this out, but we are a company that sells software for real money, and we're not a monopoly, and so therefore they're not in the mindset. Open source hasn't really sunk in, to say the least, and at some point I'm going to have to convince them. The application that runs on this is certainly something that eventually may be sold for money, and that's fine, and I don't care. But this is platform stuff. It will live or die if it's released. You're absolutely right. Anyone who wants to get his hands on this, it'll help me if there's a huge demand out there, which I don't actually anticipate, to be honest, because I know, like Eric says, good stuff, no one wants good stuff. But anyway, if you're interested, talk to me. Other questions?
Is it
Yeah.
for writing compilers?
No, it's not for writing compilers. Now, as you know, any new language, the canonical, realistic example that you have to show initially by some strange process is always a compiler. So, of course, I have the compiler, I have the parsers. It's just a neat example. People are doing domain-specific languages, they're doing application stuff. It's a fully general-purpose language. I don't see anything that's specific. This example works out beautifully, but no, it's not for writing compilers, I don't think. Yeah?
Is it always going to remain based on the Squeak VM, or are you going to build your own?
Would I like to? Yes. So it's not probably for the foreseeable future. It'll probably run for quite a while on the Squeak VM. It probably won't run for very long on the Squeak environment that you see. We're actually working on those browsers are written to our own GUI toolkit that has at its bottom a binding to Squeak's Morphic, but we're going to bind it to native stuff. In fact, there's someone working on that right now. It's starting to work. So it'll look a lot. It'll benefit from the advantage of running on real things. As for the VM, I have a couple of things in mind. JavaScript would be interesting. There's Strongtalk, which, it's very hard to justify this work in this context on VMs especially, but eventually someone will complain that it's slow, and then I'll say, oh, really? And we'll move from there.
Wonderful, Gilad. I'm glad you got out of the Java world to do
So am I.
this. Yeah. I'm glad you're glad.
And you're glad that I'm gone. Yeah. But
You said that.
yeah. I know. You.
So
kidding.
here's my question.
Yeah.
And this is what I thought the scheme influence was, but I think it's just burned into your sensibilities.
Probably.
How many different expression types are there? I saw message send, return, closure formation, 2 kinds of assignment. Is that it?
Well, there's a whole, the usual literals, integers and whatever. Those, and beyond literals, there's block literals, tuples, and so really it doesn't work yet, but conceptually it's supposed to be there object literals and literally class literals. Because another way to look at this is once you recognize that classes are expressions, this thing designs itself. If you add class expressions to Smalltalk, get rid of the statics, and say it's message-based like self, everything else just falls out, which is really my thought process. But, syntactically I haven't figured out how that looks. So there may be a few more, but they're basically sugar. Everything's a message send underneath.
Congratulations on one of the world's smallest languages.
I'll take that as a compliment.
While still being powerful.
We should probably wind down. Yeah.